Hi, and welcome back to another video. And in this lesson, we're going to go over midpoints, distance, and circles in general. All right, so as you can see, we have a few formulas that we have to keep in mind. We have that distance is equal to the square root of y2 minus y1 squared plus x2 minus x1 squared, all being square rooted. So that would be the distance between 2 points. We also have the midpoint formula, which is the center point between 2 points, like the midpoint, midway in between, like halfway in between. We have x2 plus x1 divided by 2, and y2 plus y1 divided by 2. And keep in mind, we have parentheses here and a comma in between. So these are actually coordinates. This is an x and this is a y. And one thing of note with the midpoint formula, it doesn't matter which one comes first or which one comes second. You can do x1 plus x2 divided by 2 instead, and you're still going to get the same answer. So let's just, and we also have diameter. Diameter is twice the radius, 2 times the radius. Radius is equal to the diameter divided by 2. So you may remember those from elementary school or not. All right, let's go ahead and solve the first one. Okay, it says find the distance between the pair of points. So we have 7, 4, and we have 19, 13. So the first thing you should do is label them. So this is x and y, and so are these, right? This right here is your first point. So this is the x1 and the y1 of that first point. And this is your second point, the 19, 13. This is x2 and this is y2. So all we have to do, we're finding distance, so we're just going to use the distance formula. So let's go ahead. And we're going to use d, which stands for distance. And we're going to take our y2, so this is 13 minus your y1, which is 4 squared plus x. X2 minus your x1. And you're going to square that. So, and don't forget, we're square rooting every single thing here. And just step by step, you just solve the inside and then work your way outside. So 13 minus 4 is 9. 19 minus 7 is 12. And remember, we're still taking the square root. 9 squared is 81. 12 squared is 144. We're going to add those together. And when you add them together, let's see, we get a 5 in the back, we get a 12, carry to 1, we get a 2. And now we have the square root of 225. And the square root of 225 is going to give you a 15. So if you wasn't too sure about evaluating radicals, I have a video on that as well. But for right now, let me give you a little refresher. So this is 225. This is a square root, so you need to put a 2 here because you need 2 of the same number. Breaking this down is not bad. It ends in 5, so you can divide that thing by 5. So over here, let's go ahead and do 225 divided by 5. So this goes in 4 times. We have 20. This is 25. So this is actually 45. So this is actually 45 times 5. And now we're just going to break down anything that can be broken down anymore. We can say this is 9 times 5. And then we can say this is 3 times 3. And everything is completely broken down, right? Sorry, this is supposed to be a 3 right here. Okay, so 3 times 5 times 5 will give you 225. Let's underline the ones that could not be broken down. So this is a square root. So if you have 2 of the same number, we're going to pull it out of the square root. So we have 2 3s, bring out 1, put it right there. We have, I don't like the way I wrote this. Let me go back here. Yeah, we have 2 3s. I'm going to put a square root right here. We have 2 3s, bring out 1. We have 2 5s. Bring out just one of those 5s. Now, we circled every number that was broken down completely, so there isn't going to be any radicals in this case. which means that this is a perfect square root. So 5 times 3 will give you 15, and this is how we get the 15. If you wanted to plug that in your calculator, you would have gotten a 15 as well. So the answer here is just 15. And I know you guys didn't come here for a radical lesson, but it's always good to know. This is 15 units. Good job. All right, moving right along. It says find the distance between a pair of points. If necessary, express the answer in simplified radical form. All right, that means just break down a radical and take care of business. All right, ready? So we're going to apply the distance formula again. It'll be nice, you know, always write down your points. 9,5, x and y, 1, 1, 2, 2. Okay, so you know the deal. y2 minus your y1 squared plus x2 minus your x1. I'm sorry. y2 minus y1, that should be a 3, right? I almost got caught slipping for a second. Let's erase that and put a 3. And this is the importance of labeling. All right, let me just double check. y2, which is 5, bam, minus y1, which is 3, yeah. Plus x2, which is 9, minus x1, which is 7, squared, and we're just gonna square root everything like that. Okay, so we have 5 minus 3, which is 2, it's still squared, and then 9 minus 7, which is also 2, squared. We're gonna square root everything. 2 squared is 4. You know, just solve piece by piece. This is 4 plus another 4, which is going to be the square root of 8. Now, there is no square root of 8. There's no perfect square root of 8 because 8 is not a perfect square. So what is the square root of 8? They want an exact answer in the form of a radical. So this is what we're going to do again. We're going to put an imaginary 2 here because we need 2 of the same number because this is a square root. It's a number times itself. So that's why you put a 2. And what times what would give you 8? We have 4 times 2. Then you have 2 times 2. And now this 2 right here in the radical tells you to circle 2 of the same number. If this was a third root, we'll be able to circle all 3 of those 2's. But we only have a 2 here. So we need a radical. You're going to circle, this tells you to circle 2 of the same number. So you're going to circle 2 2's and bring out just 1. For every circle you make, bring out 1 of those numbers. If you pay attention, if you do that one, if you do it like that, you're going to solve radicals no matter what. What weren't we able to circle? We were not able to circle the 2 right here, so we leave it in. And this is the answer, 2 times the square root of 2, or 2 radical 2. Yeah, so if you have time, look at that video about radicals. I do a pretty decent job. One of my first videos, by the way. Okay, it says the distance between the given points is approximately how many units? Okay, so we have to use a calculator in this case. So let's go ahead and take out our calculator. All right, good. You guys can see it. Okay, so all you do is 2. You type in 2, and then we need a radical. So to get to a radical, we're going to hit... oh, let's see. Can we use math? We could, but you know what? There's already a square root button here somewhere. Ah, there it is. It's right underneath the S square button. You see here and in blue right here. So to get to it, you hit second square root. Okay, so outside we have a 2. So go ahead and type a 2. I took my radical. Type a 2 first, is second x squared, and put a 2 here, and just hit enter. 2.828. So they wanted 2 decimal places, so this is going to be 2.83. So let's go ahead and type that in. Yeah, this is the decimal form of our answer. And that's it. That's all. And we're just going to be doing this for a while. So, you know, even if you don't get a perfect square at the end, you can break it down. And now look, they gave us radicals this time. Ooh, scary. Okay, always label x and y, x and y. 1, 1, 2, 2. Okay, so you know what comes next. We have y2 minus your y1. Now, when you subtract the negative, you know that's going to be positive, right? Plus x2 minus your x1, which is 0 squared. Now, whenever I see two negatives side by side like that, I just make both of them into plus, because negative and negative is plus, right? When you subtract the negative, everything turns into a positive. And now we can let's not forget the radical that's above it. So 0 plus the square root of 7 is just going to give you the square root of 7. Right? 0 plus anything is just that number. Square plus the square root of 11 minus 0 is just the square root of 11. And it's also squared. So let's take the square root of all this. Now we're squaring a radical. Whenever you square a radical, you just get the number 7. We're squaring this radical. We're just going to get 11. Right? Because squaring cancels out the radical. Squaring cancels out the square root. Gosh. Okay, so now we have the square root of 7 plus 11 is 18. And let's see if we can break down the 18. So we have the square root of 18. We're going to put an imaginary 2 here. What times what will give you 18? You can use any numbers you like. I'm going to choose 9 times 2. And now I know we can break down a 9, but I want to show you something. If you ever come across a perfect square, you see I'm putting a square above it. If you ever come across a perfect square, you can just take the square root of that number. So we have 9. 9 is a perfect square. So what's the square root of 9? 3. You could put a 3 on the outside. Or if you prefer, and look what's left over. We have a 2 left over. Bam. So the answer is 3 radical 2. Or you can keep using our method. You can break down everything. This tells you to circle 2 of the same number. So we're going to circle 2 3s, bring out 1. What couldn't you circle? The 2. So you get the same answer no matter which method that you use. So whichever method you like the most, you can stick with that. Whichever one you're most comfortable with. Okay, so this is 3 radical 2. Excellent. And now what is the approximation? So you need your calculator. So let's turn on our calculator again. We have 3 second x squared, square root of 2, hit enter. They wanted 2 decimal places, so 4.24. All right, so 4.24. That's it. All right, next, midpoint. All right, so now we can use a different formula. We're going to use the midpoint formula, and all we do is add the x's and divide by 2, comma, add the y's and divide by 2, and those would be your new coordinates. Okay, got it. Okay, so -9, -9, and we also have -6, -6. We have x and y, 1, 1, 2, 2. So let's go ahead and apply this midpoint formula here. It says that we have to add the x's and divide by 2. So x2 plus x1 divide by 2, comma, add the y's and divide by 2, -6 plus -9, divide everything by 2, and whatever the heck this is will be our midpoint. Okay, so this is -6 plus a -9. Whenever you have a positive and a negative side by side, that's basically just one big old negative. So if you prefer, whenever you see a plus and minus side by side like that, you can just say that this is just a minus. Okay, so we have -6 minus 9, -6 minus 9. They're both negative, so you're going to add them together and keep the sign. -15 over 2. And we're done there. We can't really break that down. And over here, once again, we're adding a negative. Whenever you're adding a negative, that means that you're just subtracting. So I'm going to erase those and just put a minus in between. So -6 minus 9 will give you -15. Yeah, had to make sure. This is our midpoint. It's kind of weird that it ended up like that, but Yeah, it is what it is. So we can go ahead and give me a second here. We can hit the coordinate button right here and just put our answer in. So this is negative 15 divided by 2 and negative 15 divided by 2. Let's delete this. I don't know why that didn't work. All right, there we go. Don't forget your comma in between, okay? And that's it. All right, midpoint. So they're being cheeky and they're just throwing fractions at us. It's okay. So we have negative 15 over 3. They're all over 3, so we don't have to find the LCD. That's good. Okay, so X and Y, label them up. Okay, so, you know, the midpoint formula is equal to, you're going to add the X's. So this is negative 13 over 3 plus negative 15, I'm sorry, negative 5 over 3. And all of that is over 2. I know it looks ridiculous, but bear with me. Comma. Do the same thing over here. We're going to add the Y's and divide by 2. So this is negative 8 over 3 plus 2 over 3. Anyways, 2 over 3, all over 2, close it up. So, you know, just step by step, go ahead and solve the numerator first. This is negative 13 over 3 plus negative 5 over 3. Wouldn't that give you a negative 18 over 3 when you add them? Remember, you don't add the denominators, just the numerators. That'll be negative 18 over 3, all over 2, comma. Negative 8 over 3 plus 2 over 3 is negative 6 over 3. All over 2. And look, they're divisible. So we can go ahead and solve what negative 18 over 3 is, and we get a negative 6 over 2. And over here, negative 6 divided by 3 is negative 2 over 2. And everything is nice and divisible. So negative 6 over 2 is negative 3. Negative 2 over 2 is negative 1. And we're done. So this is negative 3 comma negative 1. Got it. All right, question 6. It says, write the standard form of the equation of the circle. Okay, so I forgot one little thing. I forgot to put the equation of the circle in here. So just give me 1 second. Let me go to my first layer. Okay, so let me see, will this work? Nope, it didn't quite work that way. I'm going to go to my first layer. I'm going to erase this, just make some more room. Now we have a lot of formulas in this section. Okay, so there's two things you need to worry about. All right, let's go ahead and do the standard form of the circle. You know what? Let's do the center radius form of the circle, since that's what's going to be most helpful to us. All right, so the center radius form looks like this. You know what? Let me put it in orange. Okay, so center radius form is x minus h squared plus y minus k squared equals your r squared. And this right here is what they call center radius form. Now, there is also the standard form, which, believe it or not, we don't really use too often, but it looks like this. It's x squared plus, you know, ax squared plus bx plus c. But you know what? Let me see the way that they give it to you. Let me go to view an example. It probably has something a little bit better. Looks like they're not. Okay. Looks like they didn't quite give it to us this time. But you know what? We can get away with just using the center radius form for now. And plus, it's one less formula for you to, for you to memorize, right? So let's go ahead and just plug this in. It says, write the standard form of the equation of the circle with the given center and radius. So I wonder, they're not calling this, give me 1 second. View an example, Standard form. Oh, they're calling this the standard form. Back in my day, they called this center radius form. Standard form is when you multiply everything on out. You know what? It's all good. I guess this will be our new standard form. I'm going to go ahead and close this up. All right, these formulas are taking up our space. I'm going to call this standard form, whatever. Whatever. All right, so now we're here. So let's jump right in. Now, center, which means we have just one last thing, I promise. All right, so whenever you have a center is a point. The center will always be in the form of h comma k instead of x and y. H is considered your x and k is considered your y. So that's the last thing, I promise. Okay, just a little terminology in there. So how does that apply to us? Well, basically, they gave you the center. The center is going to be 0, 0. So center is 0, 0. So your h is 0 and your k is 0 because it's the center. And then we have the radius, which is r, is equal to 6. So all you do is plug everything in. You have your h, you have your k, and you have your r. So you just plug those numbers right in there, and that's it. I know it seems too good to be true, but trust me, it is. All right, so we have x minus 0 because h is 0, squared plus y. And notice I'm not plugging in for x and y. I'm plugging in for h and k. So this is y minus 0 squared, and then we have equals 6 squared. Okay, so we're almost done. We have x minus 0, which is just x. X squared is just x squared plus. Same thing over here. You get y squared, and then 36 risen to the second. I said the answer. 6 squared is 36. This is it. We're done. So the standard form is so weird. Back in my day, they didn't call it a standard form. They called it the center radius form. Standard form was something else. It was expanded. Back in my day, I sound like an old man. All right, equals 36. Nice work. All right, and that's what we're going to be doing. So using the same formula, we have x minus h. So you know what? We can just plug the numbers in and respect the signs, and it'll be good. Just plug in for h, plug in for k, and plug in for your r squared. And that's really all you need to know. That's all you have to do. So we have x minus whatever your h is, and you're not gonna be able to simplify like what we did with the zeros. You just leave them side by side. So x minus our h. All right, our h here is 6 because the center says we have an x coordinate of 6. So the h is 6. Squared, put a plus in the middle, open parentheses. We have y minus our k. Square that. Equals your r squared. Our r here is 10. 10 risen to the second power is 100. Bam, fantastic. Okay, I have something similar. Very quickly, x minus our h, raise it to the second power, plus y minus our k, second power, equals our r squared. So, this is r squared, right? So let's go ahead and delete this. Now, here's our r, square root of 6. When you raise the square root of 6 to the second power, remember we're doing this right here. When you square a radical, you just get the 6. So we are done. We're just going to put a 6 here and call it a day. Bam, nice work. Okay, write the standard form of the equation of the circle with the center. All right, it's the same thing. So in this case, we're going to have x minus our -9, which is going to be a +9, isn't it? So be careful. If they give you a negative for your h, a negative minus a negative is, when you take a minus and minus a minus, you get a plus, right? 2 negatives side by side is a plus. So this is squared plus y minus 0. Y minus 0 would just give you a y, and then you're going to end up with y squared, aren't you? So you know what? Just to test it out, Let's see if they will accept us putting a 0 in here. They did last time in one previous assignment. And we're going to put equals. The r is 3. 3 squared is 9. Let's see if they let us slide. Nope. It said it's equal to the correct answer, but that's not the form, so be careful. You don't want any zeros floating around this time. Y minus 0 is just y, and you don't have to put a parentheses. You know what? Let me see if they're going to allow us to leave a parentheses in there, even though we don't really have to. Okay, they let us slide, so you can choose to leave the parentheses if you like. All right, next. Okay, give the center and radius of the circle. Okay, so now we're going in reverse. Now we actually have the equation. And now we're going to go ahead and work backwards. So we have x squared plus y squared equals 9, right? The radius is the easy one. Remember, everything over here to your right is your r squared, right? This guy. So r squared, which is all the way here to the right, is equal to what you have all the way over here to the right. Remember, do not call 9 r. 9 is not r. 9 is r squared. So that was the mistake I used to make when I was still young. So we have r squared is equal to 9. To solve for r squared, we're going to take the square root of both sides. So r is equal to, now normally we would get a plus or minus, right? Because we just took a square root, and the square root of 9 is 3. But remember, a radius is technically a distance. So you always go with the positive one. So r is just going to be equal to 3. So that's our radius. That's easy enough. But what about the center? All right, the center depends on the left side of the equation. Now, you remember when we get an x squared or a y squared, it's because there was a 0 involved. So you can imagine if we have x minus 0 squared plus y minus 0 squared, you can imagine that this guy right here is going to be your h, and this guy right here is going to be your k. So whenever you see a bare bone, no parentheses having question like this, you can safely assume that your h is going to be 0 and your y is also going to be 0 if you don't see a parentheses for either one. Okay, so what is the center? The center is 0, 0. All right, so the center is 0, 0. The radius is 3. And let me show you guys how to plot these. So we're going to go to click to enlarge graph. The very first, all right, this is a circle. This is in circular form. So you're going to choose the circle tool. And the very first thing you go to, you might want to jot this down, okay? You want to go to your center first, okay? Do not try to go to the 3 first and like start right here or something. You don't want to do that. Start at your center. Center comes first. Then from your center, you're going to move according to your radius. Now, how do you move? You're going to move 3 units because the radius is 3. That's going to be half of your circle, right? So you can either move up, down, left, or right. You see the circle is just expanding no matter which direction we move. Do not move diagonally, okay? It's going to give you a false reading. You want to move either vertically, completely vertically, or horizontal. Do not move vertical, diagonal, okay? Okay, so let's move to the right 3 from the center. 1, 2, 3. Hit click. That's it. You're done. Good job. What is the domain? Okay, the funny business, right? So remember, domain depends on your x. So let's look at this circle and focus on the x-axis, all right? So let's go to the left side of the circle. We go from left to right when you're determining your x's, which is your domain. So let's go from left to right. What's the furthest left point here for your x? What is your x equal to at this outer reach of this circle? X has to be equal to -3, and it's solid. So we're going to put a bracket there, a square bracket, and we're going to put a -3, okay? Now we go from left to right. So starting from here, let's go all the way to the right reaches of that circle. What is your x equal to here? Your x is equal to +3. So remember, with your domain, you're going to focus on your x. And with your range, you're going to focus on your y, okay? So let's go back to the circle. We're going to find out, we have to look at our y's. So from the y's, we go from least to greatest. The smaller y's would be down here. The greater y's would be up here. So let's start from the bottom. what is your y equal to down here? Your y is equal to -3. And it's solid going through here. So it's going to be in equality, which is a bracket. So that's also -3. And let's go all the way up. There it is. What is your y equal to here at the very highest point of the circle? +3. And it's also solid. All right, so far so good. Okay, center and radius. Now, I want to show you something right quick. With respect to the formula, you see it says the center is h and k, h comma k. These are, it looks like they're positive values at first, right? In the formula, we have negatives. So your center is, whenever you have a negative inside of your formula in front of a variable like that, that means that the variable itself is the opposite. Remember, negative means opposite. So to save us some time, just go ahead and take the opposite of what you see in here. If you see a negative, your center will be positive. See a negative here for your k, it would be positive. So you're going to see what I mean. So they're asking just for the center. So let's go ahead and put a coordinate. What is your h? Your h is the opposite of this one. That'll be -4. You have to click the right arrow twice to get inside of the box, by the way. Okay, what is the opposite of this? This k right here. The opposite of -1 is +1. So whenever you see minuses anywhere, you want to take the opposite, okay? Very quickly. Look how fast we got that. Radius. The radius is r squared is equal to the 4. So if you like, you can write it down until you get comfortable. R squared equals 4. Solve for r. By square rooting, r is equal to 2. All right, now we're going to plot it. Remember, go to your center first. We have -4. So starting from 0, 0, we go 1, 2, 3, 4, and down 2. I'm sorry, up 1. Up 1. And you can see right here, I can't quite move the mouse, but your coordinates end up right here. So if you're not sure if you got it right, always look over here, glance over here to make sure that it's matching the point you're trying to make, or the point you're trying to plot in English language. So -4, 1 will be right here, right? Go ahead and click. And now we need the radius. So very carefully, either go up, down, left, or right. Do not go slanted or diagonal. The radius is 2. So 1, 2, and there's your circle. Well done. I expressed the domain. So let's go ahead and look at our formula over here. Well, let's look at our graph. The furthest left x looks like it's at -6. And the far right looks like it's at, this is negative, this notch right here, this is -2. Very tiny. I hate when they do that. If we like, we can always hit this maximize it button, and it doesn't really make that much of a difference. Well, it makes a little bit of a difference. Yeah, just be careful. Range looks like the lowest part of this graph. Let's put a bracket here since this is solid. The lowest part of this graph, look at your y's, okay? What is your y equal to right here? Your y is -1. So this is -1. What is your highest y here? +3. Okay, moving right along, it says we're going straight to graphing. Looks like this doesn't have a parenthesis, so that h is going to be 0. This has a parenthesis. It's going to be the opposite of what this is. So this center here is 0, +6. I'm just going to write that down so I don't have to commit it to memory all the time. 0, 6. That's your center. I'm just going to put C. Radius is the square root of whatever's over here at the end. 3. All right, let's go ahead and plot. So we have 0, 6. Go ahead and click. And then 1, 2. You know, we always go to the right. Let's go downward. So 1, 2, 3. Excellent. All right, domain. Domain goes from left to right. So what's the left here? The left here for your x is -3. And what's the far right? Far right is +3. Okay, range from bottom to top. The y coordinate down here is going to be 3. And up here it's going to be 9, so 3 to 9. Fantastic. And we're almost done with this. Can you believe that? All right, the center here. Center, what's the opposite of positive 3? Negative 3. There is no parentheses there, so we're just going to put a 0. Bam. Radius is the square root of that right-hand side, 3. Bam. Let's go ahead and plot it up. We're just making quick work of this thing, right? Look at us. So we have negative 3, comma 0, bam. And 1, 2, 3. Express the domain. All right, so let's look very carefully. Domain is from left to right. Looks like it's going, the farthest reach is negative 6. And it's going to go to 0. So negative 6 to 0. Range is from down to top. So what is this? This is negative 3 for your y, positive 3 for your y. All right, next. Okay, now it says complete the square and write the given equation in standard form. Okay, so I will tell you this as a precursor. Right, this is as tough as it gets right here. Whenever they give you, they give it to you in this form, you're gonna have to work and put it in center radius form. It's so funny. This used to be called this used to be called standard form, and this over here used to be called center radius form. But I whatever. I guess they just switched their game up. That's fine. Okay, so this type of problem is as tough as it gets. Okay. One thing I want you to do, let's go ahead and write it out. We're going to have to complete the square in order to get two binomials. Like this is a binomial here squared and a binomial here squared. We're going to have to get two binomials squared to get it in center radius form. And I will show you how it's done. Okay, so the setup. You're going to have to group your x's together and group your y's together. So to do that, you have x squared. What is our other x term? We have 6x, so I'm going to put it right next to the x squared. And I'm going to leave a space just like that, and you'll see why in a second. All right, plus, let's write our y terms. We have y squared. And then we have the other y term, which is 6y. And we're going to leave a space. And we're going to say this is equal to. Now, notice the 9 has neither an x or y. It doesn't have an x or a y in it. So we're going to bring that over to the right by subtracting it, and we get negative 9. Now, you see I have two spaces here, two blank spaces. We're going to have to figure out the c term that makes it a perfect square trinomial. So we're adding something here. So we're going to be adding something here because in the rules of algebra, whatever you do to one side, you do to the other. We're going to add a space here. So we add a space here. We're adding a space here. So we're going to add another space. So this is the setup. And we're just going to take it from here, right? So how do we complete the square? If you remember from one of my old videos, I'm going to put this in line. To complete the square, so CTS. To complete the square, you take your b term, you divide it by 2, and then you square it. And that's it. So what is our b term here? Our b term here is going to be 6. 6 divided by 2. Oh, that looks like a 6, doesn't it? But it's a b. 6 divided by 2 is 3. 3 squared is 9. And that's exactly what we're going to put here. Rules of algebra. Whatever you do to one side, you better do to the other side. We're going to do the same thing with this y portion here. 6. It's another 6. 6 divided by 2 is 3. 3 squared is 9. We're going to put a 9 here. Whatever you do to one side, you better do to the other. We're going to add a 9 here. Now look at this. We have a bunch of 9s everywhere. Let's do the right side first. We have negative 9 plus 9, which is 0, plus another 9 is positive 9. So far, so good. Now, I want you to employ this little shortcut. You see this portion here? That's a perfect square trinomial, okay? And so is this one. If we know that we have a perfect square trinomial, I want you to do this trick right here, okay? So it's going to be a binomial squared for both of them. Remember, this plus right here is going to be this plus right here to separate them. We know these are perfect square trinomials right here because we made it. We completed the square, which means that when you factor them, you get a perfect square binomial. Here's the shortcut. This is an x, right? Put an x here. This is a y. Put a y here. Now, depending on what your b divided by 2 was, half of your b, that's what you're going to plug here. So it also depends on the sign. Maybe we'll get an example where we have a negative b. So basically, right before you raise it to the second power, whatever sign it is, that's what you're going to use here. So look. If this is a minus, put a minus. If this is a plus, put a plus. This is positive 6. Positive 6 divided by 2. Take half of it. Half, you get 3. Same thing over here. Whatever half your b is, put it there, which is the 3. And that's it. We have the center radius form. Excuse me. Okay, so let's go ahead and input those so we know what to do with this. Let's go ahead and put this in. So we have x plus 3. Now, this is as tough as it gets, so you might want to spend some time on practicing completing the square. I know completing the square is a little weird, but it can be done. Just follow the formula, follow the steps that I did here. And I also did it in a previous video. Where are we? Yeah, we're going to raise it to the second power. There we go. Good job. What is the center? Remember, the center is always the opposite of the first one and the opposite of the second one. So the opposite of this will be -3. And the opposite of that would be another -3. Close parentheses. Bam. Well done. What is the radius? The radius is always the square root of that far side on the right. Square root of 9 is 3. Nice work. Now we're going to graph it up. So -3, -3, so -3, -3, and look at the upper right portion of this screen here. It says -3, -3, so we're good. Radius is 3, so go in any direction, not slanted, but either up, down, left, or right. So 1, 2, 3, bam. All right, no domain in range. That's really good. Okay, so let's keep on going. Let's keep moving. Okay, so let's go ahead and I'm going to go ahead and start setting up. Now that we know how to complete the square, I'm going to write the x's together, leave a space, put the y's together. So -6y, leave a space, equals, the constant has to be brought over because it doesn't have an x or a y. And I'm going to put 2 spaces here. Let's not forget our plus. Let me make sure you guys can even see that. Yes, you can, barely. But don't worry, I'll speak it out. All right, so half of -2. -2 divided by 2 will give you -1. -1 squared is 1. And remember, we're completing the square, so CTS. We're taking your b divided by 2 and you're squaring it, okay? So half of your b is -2. I'm sorry, -2 divided by 2 is -1. -1 squared is +1. Do the same thing over here. Oh, you added a 1, so make sure you add a 1. All right, -3 divided by 2 is, damn it, I said the answer. -6 divided by 2 is -3. -3 squared is 9. Add a 9. Add a 9. All right, good. So let's go ahead and factor it up. We just created some perfect square trinomials. So they're going to have some perfect square binomials. Let's add this up. 1 plus 9 is 10. 10 plus that is a nice 36, which is a perfect square, by the way. That's good. Okay, the trick, let's do the trick. And look, we have a negative this time. You know we're going to put an x in front. What is half of -2? What is -2 divided by 2? -1. Over here, what's -6 divided by 2? -3, and we're done. Good stuff. Good stuff. So you just know what to do when you're completing the square. Follow the steps. Know when to take half of the b term so you can go ahead and make it into a perfect square binomial. All right, got it. Nice work. Center, opposite of that is 1. Opposite of this is 3. Radius, the square root of the right-hand side, 6. All right, graph it up. So 1, 3. And then the radius is 6. So 1, 2, 3, 4, 5, 6. Bam, hit save. Got it. Next question. All right, good. Okay, you know, for kicks, just to flex a little bit, I'm going to do this all in my head because I know we're going to bring the 36 over to the right. I'm sorry, the 35 over to the right. And this y squared, that's the only term. You know what? I'm not going to do this in my head. Let me not flex on you guys like that. This is for you, not me. I'll flex later, I promise. So we have this plus a space plus the y squared. And then we have, I'm going to put a plus a space here too, but you're going to see why we don't really have to. So this is the only y term here, right? If that's the only y term here, which means you don't have like a 2y or a 6y or something like that, you don't need to add anything. The b is technically 0. 0 divided by 2 is 0. 0 squared is 0. So you're adding 0, which doesn't do anything. So whenever you have a solitary variable square, just leave it alone. Because that particular k term is going to be 0. Anyway, half it, square it. So take half, you get -1. Square it, you get +1. Whatever you do to one side, you do to the other side. This is a perfect square trinomial. Factor it up. What is half of your b? What is -2 divided by 2? -1. Plus, you get y squared, and this is just a 36. So we're done. Look at that. So fast. So here's the equation. We get x minus 1. Whole thing is squared. Plus, we get y squared. And this is equal to 36. Center of the circle. The center is going to be the opposite of the -1, which is +1. The opposite of, this is a 0. We know 0. Radius, the square root of the right-hand side, 6. Graph it up. So we have +1, 0, which is right here. And then let's go 6 to the right. 1, 2, 3, 4, 5, 6. Remember, count as you go. Don't look at the axis itself and start saying, okay, I'm going to go to the 6. No, you want to count six spaces from where you started. So 1, 2, 3, 4, 5. So you should be at the 7. All right, good job. All right, next. So do I flex? No, I can't flex because we're going to have a fraction here. And I can tell because we have a -x sitting there, but that's going to be a fraction. I wonder how we're going to do that. So I'm going to write the x terms together. Minus x. And let's add a space since we have a trinomial, plus the y squared term, plus the other y squared term, plus a space, equals the constant term that we couldn't use. We're going to bring that +4 over. So we're going to say this is -4 plus 2 spaces. So take a look at this. Your b term here is -1, right? We're going to take the -1 and divide it by 2. And then we're going to square it. Now, you know something? I want to show you something interesting because we know that's what we're dividing, right? Even before I put this here in a space to save you some time. And this is a pretty naughty practice, but this is going to be -1 over 2. So as a shortcut, whatever this is here, before you raise it to the second power when you're completing the square, that's what's going to go right here. So don't worry, we're gonna do it the right way, but I just want to, just show you that shortcut is whatever half your b is, that's what's going to go over there. Plus half your b here is yeah, let's go ahead and just for kicks, we know that's going to be a +2 because the shortcut says we can just do half of our b and square it, equals, okay, now we gotta really we have to put the appropriate numbers instead of cutting corners. So what goes here is when you square this, so that'll be 1 over 4, because this is 1 over 2 times itself. Multiply numerators. 1 times 1 is 1, 2 times 2 is 4. So you multiply straight across when you're multiplying fractions. So you get 1 over 4. You're adding 1 over 4 over here, so you're going to add 1 over 4 over here. What else do we have? We have 4 divided by 2 is 2. 2 squared is 4. We're going to add a... look how that worked out. The negative 4 and the positive 4 will actually cancel. So they let us off the hook a little bit. So we're just left with 1 over 4. So the center is going to be the opposite of this, 1/2 for your x, which is your h. I want to put both of them like that so you know that they're the same. And over here, we have the opposite of this, which is -2, which is your k, which you know is y. Okay, your radius. Your radius is going to be the square root of that right-hand side, which you know is the square root of 1/4. All you do is take the square root of the top and bottom. What's the square root of 1? 1. What's the square root of 4? 2. You're done. So I know the fractions are weird, but it can be done. All right, let's go ahead and put our brand new fancy function in. And remember, the center radius form was here. Okay. So let's see, we have x minus 1/2 plus we have y plus 2 and then this is equal to 1 over 4. Fantastic. It's always so good when we get them right. Okay, opposite of that one. The opposite of negative 1/2 is positive 1 over 2. The opposite of positive 2 is negative 2. Remember, we're getting that from the y section. Nice work. Radius, the square root of your 1/4, we already got that. 1 over 2. Good job. All right, let's graph this thing up. Do we have halves? Yes, we do have halves. So that's really good. That's good. That's good for us. They normally don't do us dirty like that. They do us dirty, but not like that, right? They have a limit to their dirtiness. Anyway, let's go to the center. Positive 1/2, which is 0.5. You see it up there in the upper right section, right up in here. So 0.5. And then down to 1, 2. You see I'm at the 2. I'm not saying that this is 1. Like, you don't want to say 1, 2, 3. No. This is 1/2. 1, 1.5, 2. 2.5. So just be careful, take your time and count. Look at the numbers that's over here on the axis itself. Anyway, so 1/2, comma -2. 1, 2. You are at the -2, right? And look at the upper right. Is it 0.5 comma -2? Yes, it is. Radius. The radius is 1 over 2. Well, every space is worth a half, right? So just move over 1 space. Well done. Okay, last one. Man, we made it this far. Okay, find the coordinates of the circle center. It intersects the circle at 2, 2. They have a line segment going in between. That looks to me like it's the diameter. And looks like we're finally going to use the diameter formula a little bit. And you're going to see how we use it. We got to get the center. Remember, halfway through the circle is what we call the center, right? They gave us the coordinates of the ends of the diameter. Like this is 2, 2 way down here, and up here is 4, 14. So, we're going to use the distance formula. We can use the distance formula and divide it by 2 to get the distance of the radius, or you can find the actual midpoint to get the center. Oh, we actually do have to do both. We have to do both. We're going to do both the distance and the midpoint formulas. Okay. I'm sitting here thinking we have a choice. We never have a choice. All right. Anyway, here's what I'm saying. Right. We want to figure out what the center is, and there's a line segment going through it. This right here will be the center. The center is in the middle, so it's the middle point. So you're going to use the midpoint formula to get your center. So to get the middle of the point, you have to figure out what this point is, which we know, and figure out what that point is, which we know. Find the middle between those, and that's your center. We use the midpoint formula for that. Now, the distance formula. The most clean way, it will be to just find the distance of this whole thing right here, like going from here to here, like that whole distance. That'll be the diameter. And halfway would be your radius, right? So we can find the distance of the whole line, and just whatever the heck we get, we just divide the thing by 2, and that would give us our radius. So let's just jump right in. Sorry for making an ugly circle. All right, so the center. What is the center? The center has to be the midpoint between this point here and that point there. So let's go ahead and do it. Let's find the midpoint between 2, 2. And 4, 14. Oops, this is 2. These are the second set of points, right? So they get 2s. Okay, let's do it. So midpoint formula: add the x's, divide by 2. Add the y's and divide by 2. Easy enough. 4 plus 2 is 6. 6 divided by 2 is 3. 14 plus 2 is 16. 16 divided by 2 is 8. This is our center. So we got the center. Yay! Let's go ahead and put a box around the center. Now what? We got to get that radius. The radius will be this diameter here, halfway through. So right here. So, you know something else? You know what's funny? We got the center, right? So we already got the center. We have this point, and we already have an outer edge. Remember, we want this length here. Couldn't we just use the distance formula between those 2 points? So instead of dividing by 2 and doing all that crazy stuff, how about you just use the distance formula from here to here? And you know what? I will show you both ways so you'll see that you're going to get the same answer. But yeah, let's take it from here. We know the center is 3, 8. So this is 3, 8, right? I hope you can see that. And over here is the 2, 2. How about we just find that we take the distance formula of that so we can get this whole distance, which is our radius. So yeah, I'm going to erase that. All right, so I'm proposing we use 2.2 and 3.8. Just find the distance between those 2 points. So I'm going to call this radius, since we know once we find this, it's going to be the radius. And I'm going to call it r. So r is equal to the big old square root. Remember the distance formula up here? y2. And you know, I'm going to consider this my y2 and y1 just for right now. I mean x2 and x2 and y2. Yeah, so don't focus on this one. Okay, so this is going to be my new x2, y2. So it's y2 minus your y1 squared plus x2 minus your x1 squared. So 8 minus 2 is 6. 6 squared is 36. Plus 4 minus 2 is 2. 2 squared is 4. You're going to get a square root of 40. We're going to break that down in like 2 seconds. So let's do it over here. Square root of 40. Let me make sure you guys can even see that. Yeah, you can. So what is this? This is 4 times 10. 10 will be 2 times 5, so we can just leave it like that. It's not going to be a perfect square. We're not going to get 2 of the same number. The square root of 4 is 2, so that'll be 2 radical 10. And that's it. That's the radius. Man, that was good. Oh, and I did promise that I was going to show you the other method. We can take the 2 original points they gave us from the end of the segment and find the distance formula, find the distance between them, and then divide by 2. So remember, this is the diameter, right? By taking the distance from the whole circle from here to here, that'll be the diameter, right? You want half of that, so you divide your answer by 2. So we know it's going to be 2 radical 10. You know, let's put the answers in since we're here. because I know you might not want to stick around for all that. I do think of my viewers. I don't want to waste your time. Center is 3,8. Fantastic. Radius is going to be 2 radical 10. It's very important that you break down your radicals. If you would have left it as the square root of 40, you would get it wrong. Let's test it out. If we don't break it down, square root of 40. Yeah, so it's 2 radical 10, okay? So 2 radical 10. Uh-oh, what did I do? What did I do wrong? Radius. The radius is the distance between the center and 2 radical 2. Did I do something wrong? 8 minus 2. Let me see. Let me backtrack. Y2. This is our Y2. This is our Y1. So 8 minus 2 squared. And then we have 3 minus... Oh, why the heck did I put a 4 there? This is a 3. Oh, I know, because I took it from here. I told you guys not to take it from there, and then I went ahead and did it. All right, so this might be a perfect square. And if it's not, we'll still handle business. So please excuse my little mistake. Why am I erasing this? All right, so please excuse my little mistake there. I almost went without making a single mistake this video. All right, so 8 minus 2 is 6. That's 36. 3 minus 2 is 1. Yeah, that's more like it. So we get 1 squared, which is 1. So that's the square root of 37. And there is no breaking down the square root of 37. So this is just, man, that was a close one. Square root of 37. Fantastic. Equation is going to be x minus your h, which comes from your center. This whole thing is squared. Plus y minus your k, which is negative 8, so minus your k. I mean minus it. And then you're going to square it. And this is equal to... Remember, your radius ended up being the square root of 37, right? That's your radius. But we want your radius squared, so you can square both sides. So you get r squared is actually equal to just the regular 37. All right, fantastic. And look, I did promise you that I was going to show you the other way. You can end the video. Thank you guys for watching up to this far. This is for the people who want to just use the original points, the original end segment points right there. And then we're just going to divide it by 2. And that's to show you guys that that's another way we can get our radius. So really quickly, let me go here. Let's get the original points. Maybe that's why, because we're jumping around so much, or I'm jumping around so much. All right, we have 4, 14, x and y. This is 1, 1, 2, 2. So yeah, good old-fashioned distance formula. Y2 minus your y1 squared plus x2 minus your x1, the whole thing squared. 14 minus 2 is 12. 12 squared is 144. 4 minus 2 is 2. 2 squared is 4. That's a weird number. This is the square root of 148. So yeah, I can see why our way was better. Okay, so let's go ahead and break down the square root of 148. So I'm just going to go ahead and erase some of this for some space. Yeah, all of that. Why not? I need room. So we have the square root of 148. And remember, this is the diameter that we just found. We want the radius later, so we're going to take whatever answer we have and divide it by 2. So this is the square root of 148. And let's keep on breaking it down. So let's divide by 2. That's going to be 74. Divide by 2. That's going to be 2 times 37, right? Half of 74 is even, so you can divide it by 2. 37 cannot be broken down as prime. Do we have 2 of the same number? Yes, we do. We have 2 2s. So bring it out. What couldn't we circle? The 37, leave it in. And this is the diameter. we came here for the radius though. And to find the radius, you take whatever answer you got and you divide it by 2 because it's half. And the 2's cancel. And lo and behold, we have the square root of 37 once again. So, thank you very much for watching this video. Yeah, you see, all of us mess up every now and again. Thank you so much for subscribing, and go home.